In this video we're going to be looking at the basic functions of Microsoft Excel. We're going to look at using it to perform basic mathematical functions, auto sums, sorting, filtering and producing charts. So in terms of why we'd use Excel, normally we're going to be using it to handle data mathematically, whilst in your workplace you might use it for general sort of data handling and holding just account numbers, phone numbers and things like that. It was really originally designed to handle the data mathematically, by which I mean we're going to be calculating totals, averages, performing simple or complex mathematical calculations, and then representing our data with a variety of different graphs and charts. In terms of how to use this, both in a basic concept and in terms of what you'll need for your level 1 and level 2 functional skills ICT exams, the easiest way to demonstrate that is to have some real world examples in front of us. So let's have a look at how we can implement from the basics to some of the more complex things, some of the different functions in Microsoft Excel that you're going to need to use. So the range of things we need to do in Microsoft Excel varies, but we're going to start from the basics and try and work our way through some relatively realistic examples. To begin with, one of the basic things we'll need to do is just simple maths, so addition, subtraction, multiplication and division. And to do that, we've got an example here where we've got some mobile phones. They're all real ones, so hopefully I won't get sued, but we should be okay. And we're going to calculate our total price. So we're going to use a multiplication here, but the method we're going to use here will work for any kind of simple two-step calculation. And what we want to do is we want to multiply together our quantity and our price. To do that, we're going to go in the cell that we want the formula to go in, and we're going to start off by typing an equals, because an equals is how the spreadsheet knows we're about to give the spreadsheet a command. If we don't put this in, no formula will work, because this is what the spreadsheet looks for when it's looking to run any kind of function. Rather than typing the numbers, we're going to use cell references, because rather than typing in, for example, 3 times 1100, we're going to click the cell instead and multiply it together like so. And what that means is, by using these cell references, if that data was to change, the formula's answer would update automatically. In a sort of real world application, it just makes life easier because there's less things you have to update, whereas if we're doing the exam, we'd need to do this as a minimum to get the marks, because especially on the level 2 but also sometimes on the level 1, to get the marks we need to be doing things in the simplest, most ergonomic manner. So whereas we could do 3 times 1100, they wouldn't give you the marks, because if your data was to change, your answer would then be wrong. So here I've used the little asterisk for multiply, and that's because we can't use a cross, for example, for multiplication, because the spreadsheet won't understand it. Similarly, how we haven't got a divide key on our keyboard, we'd have to use the slash as underneath the question mark or around the number pad at the side in order to divide. And this sort of formula would work for addition, subtraction or anything like that. So here we've got B11 multiplied by C11, and we can see it gives me the answer of 3,300. From there I can populate that down using the green blob in the corner, and it will replicate that. And because I've used the cell references, rather than just saying 3,300 over and over again, we can see how it's updated, and B11 has become B12, become B13, become B14 and become B15, and so it updates downwards. We can use that to populate across as well, so if we were doing calculations at the bottom of a row at the end of each column, we could do that all the way across the row and it'd do the same thing. As well as that, we can make this as complex as we want. So let's say, for example, we wanted to calculate our quarter 1 income for the following people. So we need to add up January, February and March. So here we've got more than one sort of section we need to add together, but the same logic would apply. And we just select our cell references for each one and go on past the 2 onto the 3, or as many as we needed to get our answer. And again, to copy that down, we can just use this green blob in the bottom right to copy it down and replicate it downwards, because we've used our cell references. You don't just have to use cell references though, you can use figures as well if there's something you need to multiply out by, like a common coefficient or something like that. So here in this case, to do our bonus, we need to find their quarter 1 income and multiply it by 0.05. We could do that in the same way, because we can use a mix of cell references and figures if we've got like a constant that we need to keep as we replicate the formula down. So here we've got E26 because we've taken our income and we've multiplied it out by our coefficient, which in this case is 0.05. And as we replicate that down, we can see while the cell reference changes and it updates each time, our 0.05 stays as a constant, which allows us to make those calculations populate down as we need them to. So the formulas we've looked at so far, we've typed in manually. So if we go back to our maths functions, you can see we've sort of had to type these in, had to select all of the elements that we want, and we've done them one at a time. But if we're adding up like a large range of data, or doing averages, or anything that involves like a big array rather than just 1 or 2 elements, sometimes it's easier to use the auto sum function to do that for us. Now we're going to look at how we do that manually using the sum function, the average function and things like that, but also how we can use the insert function tool in Excel to do that for us. So we're going to look at sort of like the old-fashioned way, then we're going to make it really lazy for ourselves afterwards. So here we've got some data on how many iPhones were sold between 2010 and 2019. We've been asked to calculate the total number that was sold. So we're going to have to add up a large range of data. Now while it might be tempting to just do what we did before and just keep adding them up one at a time, doing a cell reference for each one, in an exam situation this wouldn't get us the marks because this isn't the most ergonomic way of doing it. It's also really messy, and say you had like 100 pieces of data, you've probably got better things to be doing than adding it all up like this. So what we'd use instead is we'd use the sum function. So it'll start in the same way with our equals, because that's how you tell the spreadsheet you're about to do something. And if we type the word sum, it'll come up in a list underneath where we're typing. Any sort of formula that pops up like this, that is your prompt that you need to open a bracket. When you open that bracket, it comes up with a little bit of guidance underneath where you're typing for how we lay out the formula. So at the minute it's listing it a number at a time, so number 1, number 2, number 3 and things like that. But we're going to make life easier for ourselves, and once you've opened your first bracket, click and drag all of the data we want to add together. And you can see it's separated our first and our last cell reference with a colon in the middle. So what that means is it's going to add up all of the data between this range, inclusive of your first and last cell reference. If we close our, if I don't click the wrong thing, if we close our bracket, oh it's all gone wrong, here we go. So if we click and drag, I don't press the wrong thing and press enter, and we close our bracket, we can see it will add together all of the numbers that we've got and give us our total, in this case 57 million. Now we don't always have to type that out ourselves, sometimes we can make the spreadsheet do it for us, which means I don't press enter by accident, you don't end up doing what I just did and doing all the wrong thing about 10 times. So if we click where we want the formula to go, towards the top of your spreadsheet we can see we've got this insert function button. If we hit that, it comes up with a list of all the most commonly used functions within Microsoft Excel, and we can pick one of these, so in this example sum, and if we single click on it, it will give us an example of what that formula does. We're again still going to do the sum function, so we can press OK. Now it'll always try and guess what data you want to add together. So because we're at the end of what it considers a row, you can see it's put in A13 to C13. But that's not really what we want. So whilst if you're at the end of a column or the end of a row when you want to add it together, it's normally quite intelligent at picking it up. It's not always the gospel truth, so you want to like double check it's picked the right thing for you. If it doesn't, we do what we just did, and we click and drag what we want to add together, and it will do the same thing for us. We can do the same thing for averages as well, but instead of using the sum function where we do equals sum open bracket, we'd use the average function instead, which has the same sort of syntax. So say we wanted to average out these lap times, we'd do equals, but instead of typing sum, we'd type average instead, and again click and drag all our data. But this time I'm not being an idiot and pressing the wrong thing, so when I press enter it actually calculates it properly. We can also use the function button as we did before, but instead choose average and click and drag our data, and we'll arrive at the same conclusion that will calculate it for us. As well as being able to calculate our formulas and input any data we need to and things like that, we also need to be able to manipulate our data as well. So this will include things like sorting our data into ascending or descending order, sometimes in multiple stages, and then also being able to filter this so we can only see certain data that meets certain criteria, manipulating our data in terms of its format, how it looks, how many decimal places, is it currency, and things like that. To begin with, we'll look at formatting our data. So here we've got some information based on the chosen subject, a male and female pass rate, and an average pass rate that I've calculated using the formulas that we were looking at earlier. Now it prompts us here that we only want to show this to 0 decimal places, and at current we can see we've got 2 decimal places, 3 decimal places, 1, none, and we need to sort of uniform that up. If we select all of our data, a lot of the controls we're going to look at over this section in terms of our format and how the data looks are all included on this home tab at the top. So here we've got a number section, and we can see we've got a drop down menu that says general and a series of buttons underneath. These 2 buttons towards the right hand side increase or decrease the amount of decimals. Now because we've selected data that has a non-uniform setup, so some of it is no decimals, some 1, some 2, some 3, when we press these buttons you might notice a little bit of jumping where all of the data suddenly goes up by a lot or down by a lot. But We can increase our decimal, as you can see here it's adding more, or decrease our decimal accordingly. So here we've formatted our data to have no decimal places. Let's say hypothetically we had currency formatted data. So let's say this was a price, for example, instead of a pass rate. Our drop down menu here, a current that says number, has a list of all the most commonly used number formats. Now there are lots and lots of different ones and custom ones we can set up, but predominantly speaking, the main ones you're going to need are these ones in this list here. And we can see it gives us a preview of how that data would look in that format. Worth noting, spreadsheets deal with data as numbers and format it after for our benefit. So when we're doing formulas such as our sums, our ifs and things like that, we don't put pound signs and percentage signs on because that'll interfere with the formula. That's why we've got dates here as an example where, for example, the number 60 is giving us an option of giving it as a date, because spreadsheets even hold dates as numbers, with one being the 1st of January 1900, ranging up, and it formats it after the fact. That's why it's so important when we're using the contents of cells in data in our formulas, we use cell references, or we're very careful about how we type the numbers and don't put pound signs and percentage signs on. As well as being able to format our data, we need to be able to sort and filter it. So let's say, for example, I've got my information here and I want to sort it in order of the average pass rate, highest to lowest. What we're going to do is we're going to select the data I want to sort, and we're going to use on the Home tab this sort and filter button far over to the right hand side. And we've got two options at the top predominantly, smallest to largest, and the largest to smallest. Now, you might not always have a clear sort of example of them saying this in your exam. So if we're speaking from a functional skills exam point of view, they might use language such as ascending or descending. Smallest to largest is always ascending, and the easiest way of remembering that is there's an A on the top here in our little diagram. And descending is largest to smallest. In our example, they've been quite clear and they said we want it highest to lowest, so we're going to choose largest to smallest. When you choose a sort option, it'll ask you if you want to expand the selection. Now, it's going to be very rare you don't want to do that. So what expand the selection means is, if we take our example here, TV has an average pass rate of 64%, which isn't going to be the lowest, so that's going to move a bit further down. Expanding the selection means it's going to move the rest of that row with it. And there's not really going to be a situation where you're not going to want to do that. So we're going to leave it on expand the selection and press sort. And we can see it's moved TV with its 64% and all of its other data into the relevant bit. Similarly, we can use that with alphabetical data as well as numerical data. So here we have a list of suppliers, their cost, incomes and profit and loss. So let's say we wanted to sort our suppliers into alphabetical order. We'd select those and similarly use sort and filter, and this time A to Z, again expanding the selection and sorting it like so. And we can see because we've expanded the selection, it's moved the rest of the data with it. As well as manipulating our data in terms of like the order we're putting it in, we might also want to filter our data. So it might be a case of we've got a whole heap of data like we've got here, so we've got some Premier League results, and it might be that we want to filter it to only show certain data. Now, in terms of real-world application, this might be to quickly at a glance see limited information from a larger data set, or it might be that we want to produce a graph that only shows certain data from, again, a larger data set. So let's take our example here. We want to filter the table for our first one so that we can only see Manchester City's results. As a Tottenham fan, I don't know why we want to do that, but whatever. So we're going to filter this data. Now, unlike sorting where we just select the data we want to sort, filters apply downwards from the position you put them in. So normally we're going to apply a filter to a title or to a heading of the data. So we're going to select all of our headings here, and we're again going to go to the sort and filter button and choose filter. And we can see that puts a set of little arrows on each column. This arrow is the filter, and that is how we're going to go about doing it. In this instance, we've got what we would consider a simple filter, what we'd call a simple filter, because it's some really simple data. Is it Man City? So if we choose the relevant column, team for example, we can see it comes up with a list here of all of the different instances of data that appear in that array or in that column. So all of these loads and loads of data, and it repeats, it splits it down into, there are these teams being displayed. If we untick select all, I can tick the relevant team, in this case Man City, and press OK, and it will hide any other data. So we can see how my numbers on the left are being non-sequential here, and they've changed colour. Because rather than deleting the data, it's just hidden any rows that do not meet our criteria. So we can see on the left hand side it jumps from 8 to 14 to 20 to 26, because for example 9 through 13 have been hidden. If we want to unapply a filter, we press the same arrow we chose and we can clear the filter to unapply it. In terms of more powerful filters, so slightly more complex or more specific filtering, we can apply filters mathematically as well. So let's say, for example, we wanted to find teams that had less than 5 defeats, so less than 5 losses. I could go through and untick everything that is above 4, but let's say we had like a bit more data, a lot more sort of options. Say it was less than 150. It might be quite time consuming to untick all that data. So we can use this number filters option here. What that gives us is a set of options such as equals, greater than, less than, that we can use to sort of automate that process. So we wanted less than 5 defeats, so I'm going to choose less than. And it will come up with a custom auto filter, which if you progress through these videos and get onto mail merge, you'll see something similar for the mail merge as well, wherein it's going to ask us for some criteria. So we want it to be less than 5. So if I press OK, you can see we've got all the ones that have none, 1, 2, 3 or 4 defeats. Now we can stack filters as well. So it might be, as well as seeing less than 5 losses, I also want to see more than 10 draws, for example. So I can apply another filter whilst that first one is still applied, and it will stack them and they will both take effect. So let's apply a number filter for greater than 10 on the draws, and we can see both filters are still in effect. So I've still got my changed symbol here where I've got my losses less than 5, but I now simultaneously have draws greater than 10. And there's no limit to how many filters you can stack. You could feasibly have a filter on every single column if you had some really specific data you went after, and they would all apply. And then to unapply them, we just have to remember to go through and clear them individually to reset back to our original data set. Final thing we're going to look at in this video is the production of charts and graphs. Now, speaking from like a real world sense, this is going to be quite a common thing that you're going to be using your spreadsheets for, because it's quite often that you need to display lots of data in graphic format for meetings, PowerPoints, reports and things like that. From a point of view of the Functional Skills exam, they also come up quite regularly, both at level 1 and level 2, as part of the spreadsheet section. So we need to be able to know how to create them, but also how to manipulate them to get them perfect for how we exactly want them to display the data, be labelled, and what we want to see. So, in terms of creating the graphs, there's sort of 2 scenarios that we'll be in. Whether we've got adjacent data, which is by which I mean like data that touches like this, so where we've got 2 columns next to each other and it's nice and simple, or what we call non-adjacent data, where say for example I wanted this column and this column but none of the rubbish in the middle. To start off with, we'll look at adjacent data because that's nice and easy. So let's say for example I wanted to produce a graph of all these cars I can't afford and their 0 to 60 time. I would select all of the data, and I'd also select the data headings as well. This is important because that's how the graph is going to know what to label our sets of data. In this case, we've only got 2 sets of data, our labels, and some actual figures to put onto the graph. But you can do this with multiple data sets if you want to say 4 or 5 bars plotting per axis. Once I've selected my data, I'm going to insert my recommended charts. And this will give me a series of options. I can go on all and look at all the different options that are available to me, scatter graphs, area graphs, bar charts, whatever it may be, but recommended normally comes up with like what would be the best sort of options. So in this case, I'm going to pick this clustered bar chart. It will put the graph in, and to move the graph, we need to make sure we're grabbing it by the edge, because if we start grabbing it by the middle, we're going to start moving bars about, we're going to start dragging these bits about, trying to drag the graph about, it's all going to get messy. You watch none of it move now, but you get the point I'm trying to make. Grab it by the edge, and it'll make it easier. If you're going to be filtering your data, always put the graph underneath the data you're going to be filtering. Because when you filter your data, when it hides the rows, it will affect your graph. So I'll show you what I mean real quick. Let's say I was going to filter this data to only show certain times. Because my graph is next to it, it's going to distort it, and we're going to lose some information and shrink it down. So always make sure we're going to put our graph underneath before we filter. When you put your recommended chart in, it will try and give it a title. So it will look at your data. In this case, it's taking a guess that this is going to be our time in seconds. But this is just a text box as you'd have in Word, so we can change this if we need to. So for example, 0 to 60 times of performance cars, or something like that. So that is changeable. Now it's plotted all of my names down this axis, and it's put my times along the bottom, but it hasn't labelled my axes. In real world application, it might not be the most important thing in the world, but it does tend to help, especially if you're delivering these graphs at meetings as part of PowerPoints or reports, to be able to explain, without you being there, what these axes mean. And from an exam point of view for your functional skills, you need the axes labels, even if it doesn't prompt you for them, to get full marks. If we click our graph, you see we've got a little plus button here, and this is going to let us add, remove or change any chart elements we want. So if I press this plus, you can see we've got an option for lots of different things. Legends, for example, if I wanted a key, if I had a pie chart. Trend lines, if you want to sort of show correlation within your data. The table, if I wanted to show the data that the graph was formed from. Data labels, which sort of plot, what each section actually has as a value in case it's not super clear on the bars. Or the one we're actually after here, axes titles. It won't auto-generate these because we've added them, so we will have to type these in. So for example, this axis is the model of car. Hopefully I've spelled that right because I can't really read it sideways. And my bottom axis here would be a time in seconds. Like so. And that's how we'd apply any sort of specific labels we want. You can add them at your own sort of taste, I suppose, but some will be more useful than others. Like for example, if you're doing a pie chart, the legend is going to be useful to identify what the different coloured sections are, whereas for a bar chart like this, we don't really need one. So let's say we had non-adjacent data. So let's say I wanted to show a chart, if we just ignore the scenario I've got here, because this is a resource we give to our functional skills learners here. Let's say I wanted to create a chart that only showed the menu item and the charge to the customer, for example. If I just did it the way I did before, where I clicked and dragged all the data, we're going to get a lot of information in the middle that I don't want in the graph. To get around this, it's a little bit fiddly, but it applies the same sort of concepts where we need to select just the data we want and then proceed to do the same thing. If you have non-adjacent data, one of your data sets is always going to be your labels. So there's going to be the name, what the car is, or in this case the menu item, because we need that to label our data, because otherwise it's just numbers and it means nothing. So we're going to select, including the title, all of my labels like so, in one click and drag. I'm then going to hold Control on my keyboard. I'm doing this on a Windows PC. I've never had a Mac, so if you're on a Mac, I'm sorry, I don't know what it's going to be. But it'll be something similar where you can hold it to then select another set of data, maybe Command or something like that. And once I've held down that button, again in one click and drag, I'm going to get all of my second data set and then let go of Control. If I've done this right and I've done it in one click and drag and I've not held Control too early, when I press recommended charts, it will come up with some examples. And this is one of the reasons we use the recommended chart button, because it's like a last little layer of troubleshooting before I go ahead and start inserting graphs and things start going wrong. So it's worth using this sort of facility to your advantage. Because I've done it right, we have a graph. Now let's look at some examples of how that might go a little bit wrong. So let's say, for example, we hold Control too early. So I hold Control, now I click and drag. We can see, because I held Control too early, we've got this third cell selected here, which isn't data, which when I go to insert a recommended chart, we'll get an error message that comes up that it can't understand what we're doing. And then if I go in and try and insert a graph manually, again, it won't work. Alternatively, let's say I click and drag, I hold Control, and then I click, drag. Why you do that, I don't know, but let's say we do that. Again, it won't be able to come up with a recommendation because it doesn't understand the data we're inserting, because there's not any congruent data in that second data set, just a one click. So it's going to try and figure out and fail what it actually wants. And if I insert a graph manually, yeah, not what we want. So make sure when we've got our non-adjacent data, we click and drag in one click and drag, hold control, one click and drag, and they match heights. So if I pick the title on the first one and don't on the second one, we'll get the same error I just had where it will say, oh, I can't think of a recommendation, and it will freak out if we try and put in a graph manually. So something to bear in mind when we're inserting our charts. If we insert it correctly, we'll get our data, we can add all of our relevant sort of bits, so we can put our axes titles on and label it up appropriately. I've double clicked so menus come up covering up what I want, but you get the idea. And in this instance I might want to add some data labels because this graph wouldn't be the easiest to read. In terms of basic Excel, that is pretty much everything that you'd need for level 1 and for the minimum of level 2 functional skills ICT, but also from like a real world point of view, everything you can sort of use in your day-to-day work if you're working in data entry administration or something like that, to use Microsoft Excel and start to be able to use it to automate some of the things you might be doing, to present some data in formats that you might need it for reports and presentations, and generally to start to get more out of your Microsoft Excel usage.